Hello everyone, today I'm going to show you about structure approach to chest X-ray interpretation. Objective, we have only three objectives. First one is to review radiographic density. Second, review chest X-ray anatomy. And third, step approach to make chest X-ray easy. So as you know, we have five density in radiograph. First one is air. We can see as blackout, and then fat, little bit gray, and soft tissue we can see as a little bit bright gray or light gray, and bone white, and metal is more white. So this is more anatomy in chest X-ray where we should know to make clearly to see and to find the anomaly compared to normal. So here we have right and left lung schema. The, we remember there are three lobes in the right lungs, which the middle one is overlap on the right hand margin, and on the left side there are only two lobes. The left upper lobe is overlap on the left heart margin, and each lobe is divided by fissure. So here is the approach where we have to remember to begin to start to the trace wave. So like T, A, B, C, D, S. So what to do before starting interpretation chest X-ray? So the first one we have to assess for technical like control patient detail, assessing quality, and projection. So how to assess image quality? We have to know about is there any rotation? How about penetration, exposure, and expansion? And also we have to know what projection that we get from the radiograph and position also. So here is an example where we can see the technical light on the left upper image. We see a right AP IBD1, and on the left is the name of patient and uh, position. After that, we have to assess for airway. So airway, we have three points that we have to look for. The first one is trachea. Is there any deviation of trachea? Carina usually look for the tip of antitube and retitube. Bronchi, we look for any foreign body or air bronchogram. And highlight structure, we have to measure the size. Is there any suspicious for adenopathy or not? And this is the example how to assess the trachea. So we see the trachea a little bit shifted to the right, because of relative to the right upper lobe athletics. And this is also we have to assess in the air privation. So we look for abnormal air. So in this case, we see the tension, right tension pneumothorax, which show the blackout of the right hemothorax with mediastinal shift to the left. And this is also abnormal air, where we see the air in the pericardium and mediastinum and in the subcutaneous. And this is the also abnormal air where it shouldn't seen in the pericardium. So this is pneumopericardium. B, we have to assess for bone. First of all, we have to count rib. So anterior should be 6, the tip of the 6th rib, anterior rib at the mid hemitora. And if we count the posterior rib, the tens should cross the mid hemitora. And after that, we look for the vertebral disc space and look for the bone mineralization to see the opacity or any lucency lesion or fracture. So this is the case. So about the extramedullary hematopoiesis, where we can see also generalized osteopenia, and we see the enlargement of the cartilage where the anterior insert to the sternum resemble as the mass. And in this case, we see one sign we call rosary ricate, rosary, where it resulting from the enlarged anterior rib and a lunge in the one lunge resemble the rachitic rosary signs. In this case, the case of OI, where we can see very thin and long rib with multiple healing fracture. Next, we have to assess for C. C is for cardiovascular and mediastinum. First of all, we have to assess size of cardiac. Is there any signs of cardiomegaly or not? We depend on the size or diameter of the heart compared to the transfer diameter thoracic. After that, we assess about cellular sign, any occur right heart margin and left margin. And we just contour, we have to look for the mass and the size. Where normal is less than one-third of transfer thorax diameter, we look for any abnormal great vessel and highlight assessment. So this is the sample of cardiomegaly where we can see the diameter of the heart is more than 50% of the transfer thorax diameter. And this is the case of lymphoma where we can see the size of mediastinum is more than one-third transfer thoracic diameter. And this is the example where we can see the right heart border was pure, which is the case of right middle lobe pneumonia, and another one is occur left hand margin, which is the case of left upper lobe pneumonia. Next, we have to assess for D. First of all, we have to see the normal level of the diaphragmatic dome, where the right is usually higher than the left, around 2 cm or 1 specific. And we have to find any pathology like effusion, pneumoperitoneum, and phrenic nerve palsy. So this is the example of the pleural effusion where we can see the double lines at the coastal phrenic angle where indicate for bilateral pleural effusion. And we see the dome of left hemidiaphragm is elevated on the left image. And on the right image, we can see the right hemidiaphragm is elevated. So this is the case of the diaphragmatic eventration. And this is the case of congenital diaphragmatic hernia, where we can see the spleen, some bubble air of the intestine in the left hemitract. And we cannot define the definite left hemidiaphragm. And the next, we have to assess for E. E means equal lung field. We assess for the lung volume and opacity in both lung and any medical equipment in the chest. So here is the example of the unequal lung field between right and the left. We can see the left lung is a little bit lost lung volume due to the lung athletasis in the left lung base, and we also see different opacity in the right middle compared to the left sides. And next, also about the E, we see the difference between right and left lung volume, and we see the difference between opacity in the right lungs and left lung. Another case also saw about the difference between lung volume and lung opacity in both lungs. Again, also we can see in this case of that which is the case of uh, foreign body. So we can see overinflation of the left lung compared to the right. It caused the near structure shifts to the right. And this case, we want to show about how to and why to need to assess the soft tissue. So this is the example of subcutaneous fat as subcutaneous emphysema indicated by blue arrow. And we can see an equal lung field in both lungs. And we see the hydropneumothorax in the right line, right hemitract. And this is also indicate for abnormal soft tissue. We have reconfirmed the lymphoma in the left axilla. This is the reference. So in order to read and don't miss about the chest X-ray interpretation, we do not forget about T, A, B, C, D, E, S. Thank you.